Hello, everyone. Welcome to our next episode of Cilium and networking and all the fun stuff in between. Akansha, Dan, how are you both doing today?
I'm good.
Yeah, I'm good. I've recovered from KubeCon, I think. The ever-growing, long conference that it's becoming these days is a exhausting experience.
Yeah, you know.
KubeCon.
Yeah, Akansha, you weren't at KubeCon, right? I don't think you were.
I was not, but yeah. It was, the vibe was all over my feed on Twitter, LinkedIn, everywhere.
Yeah. Actually, like when I think about like all the noise that was being made on Twitter and LinkedIn and just all the other places, like even Instagram, I was like seeing all this KubeCon stuff, and it's really nice to see all the activity and noise surrounding it. But I'd like to welcome our viewers today. Thank you for joining us. I have to double check something because I'm not sure if it's streaming to LinkedIn. There were some changes to our StreamYard setup, and I never had an opportunity to test and see if it actually was reflected. So I don't know if anyone on the back end wants to, double check and see if the stream is coming through on LinkedIn. That'd be great. Anyways, today we want to recap some of those Cilium sessions at KubeCon. I know that there was an entire Cilium Con day or eBPF day or whatever. Y'all can go check that out. That's fine. That's dedicated specifically to just Cilium. But the reason why I want to bring up like KubeCon and Cilium sessions at KubeCon is because we're talking about workloads running on top of Kubernetes at scale and how Cilium is helping optimize that, but from the lens of Kubernetes, not from the lens of Cilium. And I wanted to drive this perspective more so because I wanted folks to understand that there is a lot of different areas, a lot of different problems that Cilium as a CNI and service mesh is solving. And like, I never got to catch all the sessions at KubeCon. To be honest, like I probably caught 2 total, and they weren't even Cilium based, but I was catching all the noise. Like Billy was throwing out so much content and info about the sessions that were going to be present. And so I feel like we should spend some time reviewing that, and folks should also dive deeper, watch some of these videos and understand like how Cilium has come along, how far along it's come, some of the advancements, some of the advanced capabilities, and so forth. Dan, I actually wanted to start with your session because, it was funny. I was combing through the sessions and I saw a lot of noise between your session with Nico around, the getting back to the B6 or something like that.
Yes, yeah.
Why don't you tell us a little bit about that session? What was the inspiration behind why you decided to create yet another, Cilium introduction, despite there being so many out there? And at the same time, like, talk a little bit about your network engineering mindset that helped drive that perspective of that session as well, because I saw a lot of that flavoring as I was reviewing the session.
Yeah, sure. So, I mean, that's kind of largely the initial thoughts kind of around it were we are kind of at this inflection point. I think we've kind of talked about this a few times where a lot of traditional kind of, am I bouncing around quite a lot here? A lot of traditional networking engineer folks are kind of being handed Kubernetes clusters that they now need to manage and work with. And you can kind of see that nearly every KubeCon, I think, or at least the last 5 or 6 of them, the demographics in terms of people who are new to KubeCon and it's their first time there, and the conversations we have are, there's a lot of people who are there to learn the beginning of their Kubernetes journey. Like for a lot of people who have been doing sessions at KubeCon, it's like they've been doing it for years and they just think everybody knows that. But that's certainly not the case. It's still growing massively. Yet again, this was yet another biggest KubeCon ever kind of thing. So I think at this point in time, it still always makes sense for there to be introductory sessions into various areas of cloud native technologies, and that's cloud native networking from the angle that both myself and kind of Nico decided to approach. So we the structure of the talk that we did really was largely yeah, these are networking problems that people have. You know, people need to access their applications. People need to secure their applications. They may need to encrypt things. You may know how that works in a traditional networking perspective, but you know, like there's no firewalls in Kubernetes. You know, like you had a firewall appliance and you do this, that, and the other. That is not a thing anymore. So how do we secure our applications? Well, we can do that with network policies. You know, this what a network policy looks like and blah, 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 blah. So the idea really was to kind of build up what traditional kind of networking would look like and its kind of counterpart in a Kubernetes world. Yeah, so we kind of put that talk together. We did a taster session. So we had on the ISA Valent booth, we had an area where we could kind of do lightning talks and things like that. So we did an intro session and things like that. And it was mobbed, you know, like it was a crazy experience. It was like 6 people deep, just to get like a quick 10-minute overview of what we were actually going to be talking about in the session itself later that day on the first day. And then, yeah, the session itself was absolutely crazy. So myself and Nico arrived to the room 30 minutes early, just so that we could kind of, you know, go through the slides one last time. Although I think both Nico and I at that point were kind of sick to death looking at those slides. And the room was already kind of a third full. Like this was over the lunch break, you know, 30 minutes before the session actually started. There's, you know, like there were people everywhere. So like we couldn't really practice running through things. We basically just kind of huddled over a laptop. 20 minutes to go, the room was almost full. 10 minutes to go, there was like not security, but you know, like more and more like support. You know, the KubeCon support team funneling people around and kind of moving them where they needed to sit and stuff like that. And it was kind of getting hectic. And you know, 5 minutes to go, Nico and I were kind of looking at one another and looking at the back of the room. We could see the door at the back of the room. And all you could see were rows and rows of people, just kind of like heads just trying to pop over the person in front of them and kind of see through and things like that. So it was, I think that kind of added a bit of pressure before we actually kind of started the talk itself. But yeah, wow. I mean, KubeCon's always a crazy experience. And the privilege and the opportunity to kind of go on stage and actually talk and then kind of see it kind of unfold like that perspective was bonkers. Yeah. Oop, you're on mute, Marina.
Always, as I've got the double mute going on, and you know, by now, if you're following along in this series, you should expect that from me because that's just the mistake I make every single time. But Dan, you're absolutely correct in that a lot of the sessions, actually all of the sessions, were packed. Like there was a session I tried to get to, and it was an open telemetry focused session, and there was a line out the door. And once the session filled up, like that was it. That was the end of that. No one else could make it in, not even for standing room at all. And so I kind of sat there and I was like, did we as a community, like cloud native community, like just underprepare for the level of interest in these sessions? Because every session was packed. Like I would see all these tweets and the rooms were just filled. Like there wasn't a single seat. Like normally you would expect to see like 1 or 2 seats open. Nothing at all.
Yeah.
So it's pretty mind-blowing.
Yeah, I mean the KubeCon Twitter account posted a photo from outside the door into the room that we were in, and there was just, you know, like, you could see that the room was full, but then there's just this huge line that had formed, like people queuing up to go on a roller coaster kind of thing. That was just people were hoping that they'd find a way in. But yeah, I think, I don't know, it felt a little bit like they may have underestimated the amount of people that were going to go to talks. I don't know. I mean, if every talk was vastly overpopulated, like where does that leave people?
Yeah, that's the troubling thing too. Like there are so many great sessions out there, but then I think all of the rooms were sized for about maybe no more than 200, I imagine, per session, and even some of the rooms were smaller, so maybe no more than 100, 150. And that becomes hard, especially for popular sessions around observability, around like backstage, around even Cilium, right? A ton of interest around Cilium. So that actually brings me to like the next session. I'm going to share my screen because I wanted to bring up the sessions, and if all can see like even the short URL that that Sketched offers, then it makes it easy for y'all to even jump in. I just got to find my screen. And here's the thing, right? Like now that I'm back home and anytime I have time, I'm going through these sessions because the things I care about most is like, how far along has Cilium come? Like this session alone, right? You've got Liz, you've got Nico. I've never met Vlad before, but I know Palantir. Like Palantir is an amazing company for, I think now they've stepped into the world of AI, but they were doing a lot of data processing, and they were offering like private Kubernetes services for government organizations. So it was interesting to see them come on stage. And then we've got our Canadian Christine, right? So it's really nice to see her show up too. But I also noticed that she was like very present throughout the entire KubeCon, and I was like really happy about that because Canadian representation at KubeCon has been like kind of a struggle for the last little while. So to have one of our own be up there on stage several times was phenomenal. This session was interesting because it's really about where Cilium has gone, and the thing that really popped up is this, like cluster mesh. I know it kind of seems grainy right now, but the fact that cluster mesh now gets up to 500 clusters is mind-blowing. And why I bring this up is because like when you're thinking about edge compute environments, or you're thinking about building your own little private cloud that is actually not little but very distributed, it really is a testament to the fact that Cilium is battle tested in that regard. It can withstand that level of scale. And look, there aren't many companies out there that are operating this many levels of clusters or this amount of clusters. There are, and they exist out there, but you're likely also going to see a consolidation of less clusters, more nodes as well. So it's interesting to see where this dynamic is going. We're seeing a shift towards even on-premises based workloads as well. Heck, we've even got a little community going on with Talos and bare metal, and Dan knows exactly. Even Leon knows what we're talking about. I think Akansha's a little shy to join, but maybe she'll join us at some point. Anyways, so I love this session, folks. I think y'all should go check it out, especially if you want to really know some of the history of eBPF, some of the history of Cilium, even where it's gone from its inception to today. And you've even got some nice perspectives from folks that aren't even in the Cilium community, like Nico and Vlad. So I love that. Dan, any thoughts about this session? I don't know if you caught it or had a hand in developing it.
The session was, I think, directly after the session that Nico and Vivera and I did, so I didn't get to go to the session because I was on the wrong side of the building and recovered. After this, I was recovering for a while. But yeah, I mean, also shout out to Christine as well. She's a complete boss around all this sort of stuff. It's the cluster mesh stuff is very interesting. I briefly mentioned that the demographics of it, around 50% of attendees are there for the first time and are kind of there to learn. It kind of almost felt like the other 50% were kind of almost wizened, like I've been doing Kubernetes forever now, and I have all these old clusters that I built, I don't know, 9 years ago. And I need to kind of somehow do this, that, and the other with it. So cluster mesh came up quite a lot. I spent hours and hours on the Cilium booth through KubeCon. So I had so many different kind of conversations with so many people trying to do this, that, the other. And cluster mesh came up time and time again for like, I need to kind of join these workloads together, and I need to find some way of somehow now consolidating my million tiny clusters that people keep putting together and doing this with. And I need some way of seeing everything and things like that.
Yeah. And that's the really cool thing about like addressing like different networking challenges, and Cilium is becoming the Swiss Army knife in that regard. And I love that. And it's not just a just enough approach. it's doubling down on particular key use cases. Like I've seen BGP as functionality grow from, just using metal LB behind the scenes to actually doing its own thing, having a full-on control plane, establishing upstream neighborships, doing things like eBGP multi-hop. Heck, we've even like recorded demos about this in the past, and like a lot of that as a network engineer from like years ago resonates so well. So anyways, next session. What's the next one that we care about? So this one's by Liz Rice. And I also love this session because it focuses on the multi-cluster and multi-cloud aspect of networking. And that's always been a challenge. In fact, like she's even calling out, how we used to do a lot of that regular site-to-site connectivity or networking as well. It's funny, IPsec seems to be a very recurring theme in terms of connectivity, whether it's like branch to branch, branch to data center, branch to cloud, cloud to data center, whatever it is, whatever direction it is, because it's the easiest available tool out there. But it comes with its own like limitations, caveats, constraints, and even like overhead. So it's nice to see how Cilium has provided a take on this with things like cluster mesh, with WireGuard sitting in underneath, and the usage of like what's the overlay, VXLAN and Geneve behind the scenes. I'm going to pause for a second because there's some back channel chatter going on and folks are wondering why the hell my camera setup looks so good. And they're all thinking I'm using a DSLR, sorry. I'm not. I'm using a Google Pixel 8. And the only reason why is because I was using a Logitech Brio 4K for a very long time. We're talking like 10 years. Like I got one of the very first ones, and I was surprised to see that it's still kicking around, like it's still being sold. You could still buy it, right? And so I'm guessing mine is still pretty good, except I started to notice some glare coming in from light from like my lamp up here, and that was really annoying, especially on camera. And then I decided, let me see if I can experiment a little bit. So I picked up the Android only because I was changing phone plans. So I ended up with it. What the hell am I going to do with an Android? Well, there's a lot of different things. I can record videos. It's very good, high quality Pixel 8. Camera quality is amazing. And then I was like, what if I connected it to my Mac? And all it really was like literally a USB-C cable. And there's an option inside of Android in the settings that changes it from like a USB transfer setup to a webcam. And here we are. So very easy to do. I don't think a Pixel 8's that expensive. I mean, I think you can pick one up for now like $600 US, which is like by far way better than any of the other cameras out there, in my opinion, especially for what we're getting. And the fact that I can walk around with it, I could, take videos of other things and it becomes all in one. Maybe I might switch away from the Apple ecosystem now. Anyways, we're getting off track here. Let's talk a little bit more about this multi-cluster stuff again, because multi-cloud connectivity has always been a challenge, especially when you have to rely on a vendor or let's say a particular cloud provider's implementation approach of that connectivity. So look, let's just say you're trying to connect a Google Cloud VPC to an AWS VPC. In theory, it's very easy to do. In practice, it's very challenging to do because they are two separate domains of knowledge that you have to know. Yes, fundamentally, they're offering the same set of technologies, but now you have to comb through different areas of each platform, whether you're doing this through the API or UI or programmatically through an SDK. It doesn't matter. It's still going to be different. And I think this is where like tooling like Pulumi really comes in to come and solve a lot of that challenge as well. But let's assume it's not there, right? Let's assume that we want to use the lens and perspective of Cilium to solve this problem. Especially if we're talking about Kubernetes, this becomes very, very easy. And cluster mesh just like enables that cluster to cluster connectivity that effectively allows you to treat all of your clusters as one. Like that's how I viewed it, right? It's a logical, massive cluster, and you have the ability to control and localize your traffic flows so that you don't have like hairpinning situations. Policy can be across that entire fabric. There's so much you can do with it. Like I honestly haven't dug deep enough into the session, but that's probably where we're going with what the session is about anyways. And Liz has done a fantastic job. Like I've seen some of her other content around this stuff and has done a fantastic job about addressing the multi-cloud connectivity challenge with Cilium. Dan, Leon, Akanksha, any thoughts about that?
Yeah, I mean, I think to your point, like we can set WireGuard tunnels up, we can set IPsec tunnels up between nodes. That's going to give us some east-west connectivity between clouds. The point, and you mentioned it here, really is it's cluster-to-cluster communication. So like that internal pod network is now something that another cluster is kind of aware of. So when like you try and access a service address or in that other cluster, Cilium is aware that address exists, but it's not in your local cluster. It's in a remote cluster, and because it's aware and it controls the network, it will then take care of sending that packet to where it needs to go, whichever cluster things are actually living in, and doing that communication. So it's the fact that it's not only linking multiple clusters together, it's the fact it's transparently making the disparate networks look like they're all interconnected. I think that's the magic of cluster mesh from my perspective.
Yeah, and you know what? This is like, it's not that it hasn't been accomplished before. We've done it in different forms. Like I've seen it in the form of SD-WAN, where IPsec has been abstracted away, and all you're really doing is dropping a bunch of pre-configured devices in a lot of ways in these locations. And the magic happens at a global scale from a centralized orchestrator, which just keeps things very consistent and automated. And I think that's important too, because previously, like when we had to set up, branch to cloud connectivity, it's like I just mentioned, you are having to set up separate devices in their own, whatever set of tooling or platform or UI that you would have to set it up in to make this work. And it would be a lot of testing too. And I think the fact that we're going to a level of simplifying this, creating a disaggregated management control plane while still having like complete visibility into all these different environments is powerful. Like that's where we went, and that's where we are still are, like where we are today. And it's not that the fundamental idea has changed. We're still trying to do the same connectivity, solve the same connectivity challenges. It's just at the layer that we're solving them in. So at this layer, we're doing this for containers. This is not the be all end all solution for cloud to cloud connectivity, because if you're talking about EC2 to Google, Cloud VM instances or Azure instances, we might be even talking about a different connectivity solution altogether. So just wanted to provide that level of clarity. There are other solutions that can achieve a similar like functionality, but there are more steps to hop through. There are more integrations you have to consider as well.
I mean, I think that's it as well. It's effectively one command on one cluster and one command on the other cluster, and then hey presto, like
Yeah,
it just works. Trademark.
exactly.
Liz gave a couple of sessions. Like I saw that she even gave a session on eBPF's abilities and limitations specifically. So,
I have another tab on that one as well. And I think it was also like that one session was really about, understanding, whether or not eBPF needs to be Turing complete, right? And there's a lot of consideration around what Turing completion truly means. Anyways, we'll get to that in a second. I want to get to this one because I kind of popped it up, and it's kind of controversial to bring up, a comparison of service meshes and whatnot. I, having formerly worked at Solo, I kind of know what this talk is about, and I've seen it in different forms as well. And quite honestly, it really is a discussion about understanding how Cilium's form of MTLS isn't like Istio's MTLS. And there isn't anything wrong with that. It's just the approach at which we take to achieve that mutual authentication and whatnot. So in a nutshell, this talk really just compares how Cilium and Istio do authentication and authorized services inside of Kubernetes. The reality is, like, if you're talking about two different sidecarless technologies, you have to consider like how far along these technologies are. To my understanding, Istio ambient mesh still is in experimental mode or in alpha mode, and they're approaching a beta phase, but that's still far off. So if you're looking for something more stable, something that's going to be giving you enterprise support, you have companies like Tetrate and Solo that can offer that. But the thing is, I know that they're probably going to even hit limitations at scale as well, because not all of this is feature parity with regular Istio. I don't know, maybe Leon can comment on some of this too, because Leon is here and he's probably spent some time on the service mesh side as well. Leon, thoughts?
Yeah, I mean, the whole ambient thing is what is right now being spoken about. But yeah, I think even Cilium has a sidecarless one.
Yeah, so yeah,
I don't
that's
think
right.
I've heard of this yet.
Yeah, so Cilium does offer sidecarless service mesh. I mean, the idea is we're not injecting anything into a pod to do that sidecar-like functionality. And a lot of the service mesh-like functionality still exists. Like if you're trying to do policy or authorization, or even create that level of authentication between your services, it's there. It's the implementation details are just different. And I think if you're looking at it from, I need this, I need to make sure it's capable and suitable for my environmental needs, then absolutely. Oh, I just realized I was using the wrong AirPod Pros. Oh, whatever. Anyways, that's why I'm like, my sound sounds a little bit like weird coming into my ears. I'm like, why isn't my noise isolated? Anyways, sorry for sidetracking. The thing to consider here is, the intrusive nature of technologies, right? When you have to install something that doesn't already exist, now you have to consider what changes and what gets impacted, right? Ambient mesh, as I understand it, is not meant to be intrusive at all. But then what comes into question is, okay, if I already have something that's doing CNI technology, and it isn't much more to enable the service mesh functionality that I need, what value does another technology that adds additional complexity into my network stack do for me, right? And so it really comes down to an evaluation point. And I think that in certain cases, like at the edge where networking isn't a heavy requirement, ambient mesh does really well. But when you have to start stitching together your environments and you need some cross-cluster connectivity, you still need service mesh-like functionality, you still need access to lower-level networking, like being able to do things like BGP, you still need load balancer functionality, you tend to start to gravitate towards consolidation of tooling. And that reads as something like Cilium. So I don't know if anyone else wants to offer thoughts around that as well. Dan, I know Dan's smiling back there.
It's a funny thing. It's largely almost an architectural kind of conversation at this point. And as the session was, it's largely there to kind of do pros and cons of each architectural choice. As you mentioned, some of the design features of each approach will work better in different environments. So, political answer kind of, it depends, but I mean, a lot of it really is kind of look at what it is you're trying to achieve, and kind of do your best to choose your tools wisely, I suppose, that makes sense for the requirements that you have.
Exactly. I like this other session, by the way. It's actually not a session. It was a poster session. And this was new for KubeCon EU. I don't know what the poster looks like. I hope that, maybe they upload a visual of the poster. But it was from two, well-renowned, talented engineers, Lin Sun and Dims. And they've had a hand in a lot of stuff in the CNCF, especially in the space of Istio and Kubernetes. And, they came up with an analogy, cakes. Not an analogy, sorry, an acronym. I need coffee. I need more coffee. For some reason, I don't know why analogy popped in my brain when I was like, brain, come on, can you work a little bit better right now? I'm on
Close
camera.
enough.
Yeah. All right. So we've got this 5-letter acronym called CAKES: Cilium, Ambient, Kubernetes, Envoy, and Spire. And it's cool because when you think about a network stack, that is a network stack. That is a good network stack that offers up compute, there are guardrails for security and workload attestation and identity attestation as well. But there's so much more to just, a stack that can run compute. And that kind of had me thinking, like, have you all heard of the backstack? Okay, all right, this is interesting. The backstack is, I think, the next layer, which is comprised of Backstage, Argo, dang it, what's the C stand for? I'll come back to it. K stands for Kyberno, and C stands for, dang it, okay. I'm gonna look it up now because it's gonna drive me nuts. Backstack, here we go. Argo, like literally it's hidden. Why can't they throw the C up there?
Crossplane.
I always forget Crossplane for some reason. I don't know. And the thing is, like, Victor's like one of my really good friends too. And if he heard me say this, he'll probably like disown me as a friend, and that's totally fine because I eventually will win his heart back again. But yeah, you've got Backstage, Argo, Crossplane, and Kyberno. And we're going to start to see more and more consolidated stacks like this. Heck, maybe there's someone that sits behind or someone that's developing an enterprise offering around this one particular stack. And why this is important is this is very akin to the idea of an internal developer platform, an IDP, which also is the other side to the coin of the platform engineering platform. So I expect to see the cakes and the backstack kind of working together. Maybe cakes isn't specifically cakes. It's like a set of other underlying technologies, and that's fine too. But I think the backstack is really where it's at. I hope to see this poster, though. I want to see what it looks like. I'm not sure what it looks like. Next session, what's this one about? Oh, so this one is interesting because this is actually a scale situation. This session was about whether they wanted to use CRDs versus a dedicated etcd as a storage backend. And this is because the Datadog and Isovalent came to a conclusion that there's immense scale when you're operating clusters. Like we're not talking about 2-3 clusters. We're talking about hundreds of clusters, thousands of workloads, and being able to keep track of them can become very challenging, especially when we have to think about eventual consistency. And we have to think about making sure that databases are consistent in terms of who has all the right information, single sources of truth. And if you really think about this as a problem, this used to be a big problem when latency was a massive factor. Latency is not so much a factor, especially on the network, but then other factors come into play here too, like the availability of CPU memory and disk and how that can impact the way we would build out, a CRD or a dedicated etcd. Dan, any thoughts around that?
Yeah, I find this funny. Years and years ago when I was at Heptio, one of the endless architectural conversations we were always having was when deploying Kubernetes, should you have a dedicated set of etcd nodes and a dedicated set, your API server and this, that, and the other would sit separately. The reason for this is it means it's easy for you to scale up your etcd backend without impacting your control plane side of things. And this largely was due to the fact that I think it was Calico back in the day. Their implementation for what Calico was doing with networking meant that once you hit a certain scale of nodes, Calico would hammer etcd so much that it would make your cluster fall over. So at that point, kind of the best practices for deploying your clusters was to have etcd sit separate from your control. Now everything's all stacked. We tend not to care, but like the conversation that we're having now is we're doing those sorts of things where we are hammering those etcd backends so much that the cluster can fall over again. So this high throughput data, where do we put it? Do we optimize? Do we come up with something better, or do we do a separate etcd store, or do we come up with a new key value store that we have running somewhere else and things like that? And around we go.
Yeah, and I think we'll always go around these decisions because we'll hit scale issues again, and then we'll hit constraints, and then we'll decide, do we trade off some of these features for this level of scale? And it will always come down to decision points. And I remember like back in my VMware days, when I was designing some of this stuff, especially for NSX, the trade-off would come down to like, I would trade off a lot of these security features for the level of speed I get. Simultaneously, I want these security features, but I'm going to give up speed. But that actually translated into breaking up the environment in certain ways. And sometimes you can't treat everything as one large environment. You have to break it up into smaller pieces to be able to achieve like your specific outcomes for your workloads, whether they need that speed or they need that security. Sometimes there's going to be a level of that compromise. But even in this one particular situation, as you start to scale at CD, it's being called out. Like you're seeing diminished returns in write performance alone. And that can have a profound impact in the way your workloads perform too, because things like lookups can't be performed quickly enough. Like resource translations don't happen quickly enough as well, because everything has to be referred back to etcd. So it causes its own issues. Go take a look at the session and learn from the other side of scaling, not only just Cilium, but scaling systems like workload systems, because it will give you ideas as to some of the other challenges that Kubernetes brings about too.
Yeah, I mean, I think this session is important for anybody who's writing CRDs and doing anything that's going to generate lots of new objects within a Kubernetes cluster. It's the same problem that people are going to face.
Exactly.
So does it like tell about the pros and cons, like of
the session will dive into a little bit of both, and it'll give you an idea of how best to make those decisions around should I scale with etcd or more CRDs.
Okay, so then organization according to their use cases can choose like what they want to go ahead with. Okay.
Yeah, I think like that session is important because for someone that's making some of these architectural decisions, it's not just about Cilium, right? These architectural decisions will also impact so many other upstream stacks or downstream stacks. It'll impact the way or where you run your workloads. It'll impact the way you decide on things like data sovereignty, things like GDPR. Because you'll start to realize the guardrails and constraints that you're putting in place now also limits you in other ways too, right? So you have to start to begin to understand your compromise in that overall architecture. Anyways, we could go on about scale and limitations forever, but I wanted to just quickly touch on this other session, which is actually more of a practical implementation of doing Cilium at scale. I'm not going to spend too much time on it, but it's a Datadog perspective. So it really gives you an insight as to how they used AWS, how they allowed pods themselves to have IPs within VPCs. And that's actually a very important distinction too, because normally when you operate a cluster, right, you have NAT that's in place that shields all your endpoint IPs. But to be able to expose your pod IPs onto a CIDR on a VPC and to expose that to other VPCs is kind of a different shift. And it goes back to the way we used to do networking anyways. There are reasons and use cases behind it. Like there might be specific workloads that have like, IP requirements or hard requirements to use IPs, and they can't use DNS or host names, or they're very static. Or some developers have codified things in certain ways on EC2. Or even operators have done the same too. There's so many different reasons. We can get into it. I don't know, Dan, if you wanted to share some thoughts around that.
Yeah, I mean, I've seen directly routable pods has been a thing that's been around for quite some time. Telcos love it. Anywhere where you want to have no latency or minimal latency, because you don't want packets being natted, mangled, and this, that, and the other. You basically almost want point-to-point connectivity and stuff like that. And yeah, and things that you need to have stable behaviors and things like that. So IP addresses that are hard coded and stuff like that. Largely the kind of main use cases for it. But it kind of feels like an antithesis against like the architectural decisions that were made when Kubernetes was built as a whole. Like to have that hidden network that you don't access directly. Now all of a sudden it's like, well, we're going to access everything directly at this point anyway.
And that's just it too. I think that creates more security challenges as well. Like when you have direct access to a pod, your security team may or may not have that awareness. And if they do, they're going to ask questions, and they're going to wrap a lot of policy around that and begin to scrutinize why you've done something like this or exposed pod IPs. The intention behind using NAT devices is so that we don't expose endpoints or services that can be compromised in like a variety of different ways. I mean, again, I can pontificate about, the security implications of exposed pod IPs forever, but let's talk about some other sessions too. This one's interesting. I didn't catch the session. I didn't even get a chance to fully read it or watch it, but there's a wrapper around using Cilium network policies to provide a level of PCI certification, PCI DSS. Anyone want to chat about PCI DSS or talk about what it is?
I can talk. I did in one of my past lives. I did PCI DSS certification for a company that I worked in, and it's effectively a phone book-sized book of rules that govern security for everything, and it's largely it's a set of rules and guidelines because you're holding payment card information, you're holding credit card numbers, you're holding personal data, all of those sorts of things. And PCI DSS basically governs almost things from like physical access to the building where the servers are, down to password strength requirements on accounts, to data sovereignty and who can have access to it, and all of those sorts of things. When I did the PCI DSS stuff, it was for VMware clusters, which are largely, kind of bare metal rules can pretty much apply to it and things like that. I have not seen if PCI DSS has been updated for kind of Kubernetes-esque behaviors, but I can only imagine that it has. So, I can only imagine the people who had to do PCI DSS using the original way of doing it were probably kind of horrified and trying to apply some of those rules to Kubernetes. It just makes no sense. Like, right, we firewalled this pod, but that pod no longer exists because it's this new pod that does the same thing with a completely different IP address. Like, well, I can't do anything. How do I? Yeah. So, it's going to be quite interesting about how PCI DSS has evolved for cloud native.
The one thing about PCI, right, DSS, specifically when it comes to like European compliance requirements, GDPR specifically, like this is a big thing. And when you think about the availability of tooling to be able to achieve this, look, if you spent the time, not this specific session, but spent the time to actually review, like, let's say NIST, right, and what they suggest, or even spent the time to follow on, like, even some of the Kubernetes SIG group offerings and what they propose as the right guardrails to have in place, you'll begin to realize like they align very much well to what some of this talk is actually alluding to. Now, like network policies, you're not going to sit there and develop every single one individually. You're going to have corner cases where you will, but for the majority of workloads, you kind of have to want a repeatable pattern or a repeatable set of policies that can be used that is a catch-all, right? And this is where tools like Hubble from the Cilium side really come in to help with that, right? Look, Cilium is not just the only layer when it comes to security. You have to start thinking about, how your workloads are able to perform actions on certain things. So I know there's functionality to prevent things like a GET request or like deletes or something like that within the Cilium layer 7 policy engine, but to get very granular, this is where tools like OPA and Kyverno come in, because now you're writing policies against workloads and what they can do, how they can perform, and you're tying that to like labels and additional attributes and even conditions as well. And when you think about like OPA, you're also thinking about writing this in Rego in a programmatic sense as well as to how your policy looks. So it is very extended, but it's just a reaffirmation that when you're thinking about, the payment card industry environments and how we transact, there is a lot of security wrapped around it. Network policy and authorization are just two parts of that story. There's so much more to it. Go take a look at this session. All right, next session. What's this one about? This is Christine's session. I love this one because There was a point in time where there was some confusion as to who owns the policy layer when it comes to service mesh and CNI. And you would sit there and assess that, you've got Cilium or a CNI like Cilium or even Calico or others that offer like layer 4 network policy. Now they offer layer 7 network policy, specifically Cilium and its service mesh functionality too. And then you have something like Istio that can do layer 7 policy as well. And, to an extent, layer 4 policy. So it climbs down the stack. And you begin to wonder, who takes precedence? What actually comes first? What's the right way? Now, a lot of that confusion can be removed when you just have a single consolidated platform doing it all, like Cilium. So Dan, I wanted to ask you, right? Like what is it? What is the right order of operations when it comes to policy? Does the CNI come into effect first, or do we have the application level policy, which is like an auth policy, come in first before that network policy comes into play here? I think it really comes down to flow of traffic and how it flows, right?
Yeah, so the CNI is going to be the first thing that sees the traffic. So your network policies ultimately will see the traffic much higher up the stack, lower up the stack. They're basically going to see the frames, they're going to see the packets as they kind of come into the kernel and things like that. The service mesh policies and things like that sort of stuff is going to happen kind of much lower down, as it were.
Exactly right. There's at the end of the day, you've got a single tool that now understands all the pieces, all the layers of that stack, and it just knows how to move like a packet, or we could even say a frame to a packet to an actual request, and map it all together, understand the flow, understand the source and destination, understand the type of requests as well, and even to an extent, a lot of those attributes in between. So I love this session. Go check it out, folks. I'm actually surprised. This is only a 17-minute session. I thought, wow, okay, she's very efficient. This is what I love about Canadians. Let's keep it short and sweet and get people out of the room so that they can get to their washrooms in their next sessions. Love it. Shout out to Christine. I hope to see you soon. Actually, Christine's speaking at Kube Huddle. So I'm very excited about that. Yeah, I'm very excited about that. What other sessions? Okay, this is the one that Akansha, I think you brought up around eBPF's abilities and limitations. Hold on, do I have one more? This is the cluster mesh one. We'll come back to that. Okay, so I also did not get a chance to review the session, but I actually know the controversy behind the session. There was a lot of politics behind, eBPF, its functionality, what it is, what it isn't, what it can do, what it can't do. And like I'm very neutral when it comes to this, but I'm gonna give you the floor, Dan, right? To kind of talk a little bit about some of those challenges, some of the maybe FUD that was thrown around, and maybe talk about why you think eBPF is the right fit for a lot of the problems that we see today.
I feel like I wore the right t-shirt for this.
I love it. I wore partially the right t-shirt, but I'm almost there.
No, I can understand. I think, maybe a bit of fatigue of, kind of, you can do everything with eBPF. It's this magical thing that's going to do everything for you. And I think that kind of, I don't know, maybe, I don't think it annoys people. I don't know. Sometimes people just kind of get their backs up, but the eBPF is a continuously evolving project that's part of the Linux kernel. For those that are new to eBPF, effectively, you can write some code, you can attach it to a running kernel in a certain set of, attach it to a path of flow of execution. So we tend to do a lot of networking side of things. So we'll attach it to the networking stack, and when a packet comes in, normally it will just go on its merry way into the kernel. Now, all of a sudden, my code is sat there. The packet will go through my code. The results then are passed to the kernel, and it will then go on its merry way. I may have changed it, I may have dropped it, etc. And that's kind of what we're doing with eBPF. And eBPF is incredibly powerful, but with power comes responsibility. Yes, drop that in. So, the biggest problem is, everybody's like, oh my God, just putting code in a running kernel, you'll break everything. And that would be the case if it were not for things like the eBPF verifier. So before, when you're writing eBPF code and you'll try and compile it, the compiler will be like, no, you can't do this, you can't do that, that's crazy, that's daft, and this, that, and the other. And it can be quite a frustrating experience, but effectively the compiler has so many rules in there to stop you doing dangerous things. Now, even if somehow your code that looks like it's fine and compiles okay, has got past the compiler rules, before it is allowed to run in the kernel, it has to get through the security of the kernel, and eBPF comes with its own set of bouncers to get you into the kernel nightclub, and those bouncers are called the eBPF verifier. And the eBPF, and I argue with the eBPF verifier daily, the eBPF verifier will actually run your code before it runs for real, and it watches for loops that will go on forever. It doesn't allow those. It will watch you try and do things with memory that you may have not initialized and stuff like that. So the verifier is like the second step of security to make sure your programs can run within the kernel. So both of those things have effectively put some limitations on what you can and can't do with eBPF. And this is why it's been difficult to do everything with eBPF. You have limited program sizes, so your programs can't be massive. You can't just have loops that'll keep going until they eventually figure things out. You've got to have a bounded loop. So effectively, we need to know how big the loop is. We can't just do while forever until a condition is reached. We can basically, the loop has to go 100 times or 200 times, no more, no less, and things like that. So that those limitations are being relaxed as eBPF grows, and we come up with better ways of protecting operations inside the kernel. But those limitations effectively kind of meant we did a load of amazing stuff with eBPF, and then we kind of reached a point where we kind of done everything that was kind of capable in eBPF. And I think people then kind of started to say, it's limited. Like, you can't do this with it, you can't do that with it. It's not as good as people were kind of saying and things like that. And that's kind of, there were some truths with that, but I think as people have done more and more with eBPF, and as people often do, they found kind of not necessarily loopholes, but certain ways of writing code that's actually allowed us now to get past those, not even self-imposed limitations to a certain degree. And personally, I love kind of writing eBPF code to kind of prove the haters wrong, whatever. I mean, being able to read application data, which most people have kind of stopped short at that point with eBPF. I've recently written a DHCP server in eBPF. I could pass BGP and HTTP and HTTP headers and blah, 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 blah. And that's going past where most people have kind of gone with eBPF. And as I say, there are continual new changes. Every new kernel release comes with new features for eBPF, which are going to allow us to do more and more things. And that's what this talk was largely about. It was largely to prove that eBPF is now kind of largely only limited as far as your imagination can kind of take you. Being able to actually have, was that Conway's Game of Life actually running as an eBPF program, shows that those limitations aren't really limitations, that, with the correct, with John basically and Liz at the helm with their mass eBPF knowledge, those limitations can be overcome, is effectively, I think, kind of the point of the talk. And they were there to kind of show, the sky's the limit, basically, with enough kind of thought in terms of how you want to write your code.
I agree. I mean, I think there are also a lot of different ways to approach it as well. Like the one thing that has come up recently is WASM, right? WebAssembly. And in my point of view, right, this, a lot of people may not agree with this. I feel like WASM is in a lot of ways very similar to eBPF. It's just at the layer at which it can be operated at, right? And why I say this is because if you're able to write sandbox programs in eBPF, and you're also able to write sandbox programs in WASM in the browser based off of a little bit of a virtual machine somewhere, then technically they are the same thing, but they're solving different problems at different layers as well. And that's where, like, when I start to really dig into some of these technologies, one, eBPF feels more natural to me because I can see where the networking is. With WASM, I cannot. And that's the troubling thing for me. But at the same time, it seems to be selling in a lot of different ways and solving a lot of different problems too. So maybe we'll come back and talk about WASM at some point. All right, I've got one more session and we got to wrap up soon. And this session actually is interesting because it is a practical implementation of Cilium by a credit union in Brazil. And this caught my attention because of how big they are. So they got 47 Kubernetes clusters. They've got 2,000 applications. They're running on top of OpenStack, and they're using Cilium cluster mesh. And it's interesting to see how they've achieved that success. And it makes you wonder, like, you know, what were the shortcomings? What were the constraints? What were the decision points? What were the trade-offs that they had to make to make this all work for them? I haven't watched the entire session. I intend to, because there's some data points I want to extract out of this. But Dan, I see you like ready to say something about this. So if you got some thoughts to share about Secreti,
I saw, I saw various screenshots flying around of the actual talk itself. They talk about how they've kind of got service mesh kind of up and running using Cilium service mesh. They show kind of the practical applications of how they've actually managed to bind their clusters together with cluster mesh and things like that. From my perspective, seeing actual real world implementations of all this sort of stuff, especially, in a bank that's 122 years old, like most banks that I've kind of ever had any interaction with still typically feel like they operate like a 122-year-old generally would do. So, kind of seeing mass adoption of kind of amazing kind of cloud native technologies and seeing the impact that it's actually having on speeding up the bank's operations and, allowing them to move much faster, kind of get stuff into people's hands much quicker and stuff like that is pretty awesome.
Exactly right. And that's why, seeing real world implementations of Cilium, like technology in action, right, and at scale is like, look, that's not to diminish some of the other sessions that talk about the theoretics of what Cilium can and cannot do, but to see a real practical implementation goes a long way and a true testament to how far along a CNI has come along. Look, when I first started looking at CNI technology, like I was back at VMware, and it was Calico, Romana, Antrea, Cilium, WeaveNet, even NSX had its own CNI at the time. And when you start to see what has happened over the last few years, some CNIs kind of just fell off the radar, fell off the map, while others continue to double down in their feature set and capability. I don't know what's going on with Antrea. It was a VMware open source CNI. I'm not sure where it is today, but to see where Cilium has come along, how far it's come along. Like, look, if you go take a look at the very first Echo episode that came out, I was actually on that episode as a guest, like not a guest on screen, but I was there in the chat. And it was like very intriguing to me to see a CNI technology that like resonated so well with me and seemed so familiar. So I started just asking questions. And that was like back in like 2019, 2020, somewhere around that time. We're in 2024. Look how far along Cilium's come along. Anyways, any final thoughts before we wrap up for this session? Awesome. All right. Next week, we actually have another guest. Sorry, Dan, we got to kick you off, but we got to bring your peer on.
We got people sick of seeing me, I guess.
Yeah. No. We've got Raphael coming on to talk about Tetragon.
Awesome.
It's good because I haven't played with Tetragon. I haven't seen the runtime security side of what we can do with eBPF. And I know that there are other technologies out there that do it as well, but I want to see Tetragon in action. So let's all get together again next week, and I hope to see you all there. Thank you so much for coming by. I know this was on a Wednesday, a random day of the week, but we just had to adjust. We're all doing different things. We all got like things going on in the community and our personal lives. But I want to thank you all for coming by, and thank you, Kansha, Dan, Leon, for showing up and being excellent guests and co-panelists. Take care, everyone. We will see you all again soon.